Welcome to Math Tutorials. In this video, we are solving every question of exercise 7.2 of Chapter 7, Integrals, from the NCERT Mathematics textbook for Class 12, Part 2. Exercise 7.2 is the substitution workout. 39 integrals where a well-chosen U collapses each problem, from log patterns and powers to trigonometric and exponential forms, plus 2 multiple choice. Here is the full list, grouped. Question 1. The numerator 2x is exactly the derivative of the denominator. That pattern is the log form of substitution. Put u equal to 1 plus x squared. Du is 2x dx, exactly the numerator. The integral of 1 over u is log of u. Substitute back. The modulus is optional since 1 plus x squared is positive. Question 2. Log x squared, with the derivative of log x standing by as 1 over x. Substitute the inner log. U equals log x turns the integrand into u squared du. Integrate the power and substitute back. Question 3. Factor x from the denominator first, then 1 plus log x is the substitution. The integrand is 1 over x times 1 plus log x. With u as 1 plus log x, du is dx over x. The log integral again. Question 4. Sine of cosine x, escorted by sine x, the derivative of cosine up to sine. Substitute the inner cosine. U equals cosine x gives du equal to minus sine x dx. Minus the integral of sine is cosine. Question 5. A product of sine and cosine of the same linear angle. The double angle identity halves the work. The product is half sine of twice the angle. Integrate with the inner slope 2a. Question 6. The square root of a linear expression. Power rule with the inner slope divided out. Treat a x plus b as u with du equal to a dx. Substitute back. Question 7. X times root of x plus 2. Substitute the whole root argument. X itself becomes u minus 2. With u as x plus 2, x is u minus 2, and the integrand splits into 2 powers. Integrate and substitute back. Question 8. The x outside is a quarter of the derivative of 1 plus 2x squared. A clean power substitution. U equals 1 plus 2x squared. Du equals 4x dx. Integrate the half power. Question 9. 4x plus 2 is exactly twice the derivative of x squared plus x plus 1. The root soaks up the substitution. U equals the quadratic under the root. The prefactor is 2 du. Integrate and restore x. Question 10. Factor root x from the denominator. Root x minus 1 becomes the substitution. The denominator is root x times root x minus 1. With u as root x minus 1, du is dx over 2 root x. Twice the log. Question 11. X over the root of x plus 4. Substitute the root argument and rewrite x. With u as x plus 4, x is u minus 4. Integrate and factor the common root for the tidy book form. Question 12. The x to the fifth splits as x cubed times x squared, feeding the substitution. U is x cubed minus 1. With u as x cubed minus 1, x cubed is u plus 1, and x squared dx is du over 3. Integrate both powers. Question 13. X squared is 1/9 of the derivative of 2 plus 3x cubed. A negative power of u appears. U equals 2 plus 3x cubed. Du equals 9x squared dx. Integrate the negative power. Question 14. A general power m on the log. The same log substitution, with a power rule finish. U equals log x reduces the integral to u to the minus m. The power rule, valid since m is not 1. Question 15. X above, a quadratic below, the log form after a sign-careful substitution. Du carries minus 8x. U equals 9 minus 4x squared. Du equals minus 8x dx. The log with the minus 1/8 outside. Question 16. An exponential of a linear expression. Divide by the inner slope 2. The antiderivative is the exponential itself over 2. Check by differentiating. The chain rule restores the 2. Question 17. X times e to the minus x squared. The x is half the derivative of x squared. U equals x squared halves the integral of e to the minus u. Integrate the negative exponential. Question 18. The exponential of inverse tangent with its derivative alongside. A perfect substitution, u equals inverse tangent x, absorbs the denominator entirely. The exponential integrates to itself. Question 19. Divide top and bottom by e to the x to expose symmetry. The numerator becomes the derivative of the denominator. After dividing, the fraction is e to the x minus e to the minus x over their sum, whose derivative is the numerator. So the integral is the log of the denominator. Question 20. The doubled version of the previous pattern. The derivative of the denominator is twice the numerator. U, as the denominator, gives du equal to twice the numerator dx. Half the log. Question 21. Tangent squared converts to secant squared minus 1. Then the linear angle divides by 2. Use the identity first. Integrate half tangent of the angle minus x. Question 22. Secant squared of a falling linear angle. The inner slope is minus 4. Tangent of the angle over the slope. Written with the minus in front. Question 23. Inverse sine with its own derivative underneath. U and du pair up perfectly. U equals inverse sine x. Half u squared. Question 24. Compare the numerator with the derivative of the denominator. They differ by exactly a factor of 2. The denominator differentiates to minus 6 sine plus 4 cosine, which is twice the numerator. So the integral is half the log of the denominator. Question 25. 1 over cosine squared is secant squared, the derivative of tangent. Substitute 1 minus tangent. U equals 1 minus tangent x. Du equals minus secant squared dx. The negative power integrates to plus 1 over u. Question 26. Cosine of root x over root x. Root x is the substitution. Its derivative supplies the denominator. U equals root x, du equals dx over 2 root x. Twice the sine. Question 27. The root of sine 2x with cosine 2x beside it. Half the derivative of sine 2x is right there. U equals sine 2x, du equals 2 cosine 2x dx. Integrate the half power. Question 28. Cosine over the root of 1 plus sine. The numerator is the derivative of the roots inside. U equals 1 plus sine x. Twice the root. Question 29. Cotangent times log sine. Cotangent is the derivative of log sine, so this is u times du. U equals log sine x. Half the square. Question 30. Sine over 1 plus cosine, the log pattern with a sine. The denominator's derivative is minus the numerator. U equals 1 plus cosine x. Du equals minus sine x dx. Minus the log. Question 31. The same pair, denominator squared. A power rule instead of a log. The same substitution, with u to the minus 2. Substitute back. Question 32. Convert cotangent to sine over cosine and clear fractions. A classic split in a half of x plus half a log. The integrand is sine over sine plus cosine. Write the numerator as half the sum plus half the difference. The first half integrates to x over 2. The second is minus the log of the denominator, since its numerator is minus the derivative. Question 33. The tangent twin of the previous question. Cosine over cosine minus sine, split the same way. Write the numerator as half the denominator plus half its derivative. X over 2 plus. The second numerator is minus the derivative of the denominator, giving minus the log. Question 34. Multiply top and bottom by secant squared's ingredients. The denominator becomes tangent times cosine squared. Divide inside by cosine squared. Sine cosine is tangent cosine squared, so the integrand is secant squared over root tangent. Twice the root of tangent. Question 35. The square of 1 plus log x with the derivative 1 over x attached. Straight to u squared. U equals 1 plus log x. A third of the cube. Question 36. The bracket x plus log x differentiates to exactly x plus 1 over x, so the whole prefactor is du. U equals x plus log x. Du is 1 plus 1 over x, which is x plus 1 over x. A third of the cube again. Question 37, the last integration. A tower, sine of inverse tangent of x to the fourth. The x cubed over 1 plus x to the eighth is exactly a quarter of the tower's derivative. U equals inverse tangent of x to the fourth. Du is 4x cubed over 1 plus x to the eighth. Minus a quarter cosine. Question 38, multiple choice. Look hard at the numerator. It is exactly the derivative of the denominator. The derivative of x to the 10th plus 10 to the x is 10x to the 9th plus 10 to the x log 10, the numerator, so the integral is the log of the denominator. Option D. Question 39, the final one, multiple choice. 1 over sine squared cosine squared. Split the 1 into sine squared plus cosine squared. Writing 1 as sine squared plus cosine squared splits the integrand into secant squared plus cosecant squared. Integrate tangent minus cotangent. Option B. That completes all 39 questions of exercise 7.2. In the next video, we will take up exercise 7.3 on integration using trigonometric identities. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.